Okay, so part 2 of word problems is actually going to start with our examples, and we're going to start off talking about consecutive integers. So as we look at the sentence, let's just read through it. It says, find 3 consecutive even integers whose sum is 150. One of the things that I want you to do is circle the word is and just know that that means equal sign. And that as we change that is to an equal sign, it's our divider of sides. Anything before is on the left-hand side, anything after is on the right-hand side. So because it says is 150, we can actually create that side of the equation and say equals to 150. What the issue is, as we're looking at this, is what's on the left-hand side. So let's go back to the beginning of the sentence, and it says find 3. So I don't know what they are, but I know I'm looking for 3 numbers. So I'm just going to create a table here that I'm going to fill in with information that we're going to use to form the variable expression on the left-hand side. It says the word consecutive, which means I need to think formulas. It says the word even, so I need to look at my consecutive even integers, and those are what I'm going to put under my number 1, 2, and 3. So the formula for consecutive even integers says number 1 is x, number 2 is x plus 2, and number 3 is x plus 4. From there, the question says whose sum, or the word problem says whose sum. Sum says let's add those up. So we're going to combine similar terms and we get 3x plus 6. And that actually is the variable expression that forms the left-hand side of my equation. So now what we're going to do is we're going to solve that equation. There's no parentheses. There's no fractions. I can't combine the 3x with 6, so I'm going to box my variable term. I'm going to subtract 6 onto the other side, and I get 3x equals 144. And then again, when you take 144 and we're going to divide it by the coefficient by the x, which is 3, we end up with 48. Now notice specifically here in this particular problem, it says that I had to find an even integer. It is 48, an even number. An integer, it's non-decimal, so that condition is met. But the question also said I had to find 3. So we take what answer we got, go back to our chart and say our first number is 48. If I take 48, add 2, it gives me 50. If I take 48 and add 4, it gives me 52. So our 3 numbers that add together to give us 150 are 48, 50, and 52. I do want you to notice that we went back to the chart to make sure we answered the question. Our answers make sense for the problem, and you can add them up and see that they're 150. Now, many times students can do this in their head through a trial and error type process, and what I want you to be very careful about is to make sure that you can see this as formulas, especially the sophomores who are going to be taking that different test. You need to be able to write an equation from a bank of words. Let's move to our second example. In example 2, also a consecutive integer, it says find 3 consecutive odd integers whose sum is 183. So again, here's that word is, and the right-hand side is pretty much done. What we're looking for is what's happening on the left. So go back to the beginning, find 3. And just know that's why, again, I'm putting number 1, number 2, and number 3. I don't know what they are, but I'm looking for 3 numbers. Consecutive means go to our formulas. Look for the odd integers. So the formula for 3 consecutive odd integers, first number is x. Be careful here. The second is x plus 2 and the third is x plus 4 from our formulas. Going back again, whose sum? Add them up. And notice it's the same variable expression that we used in the previous problem. The difference is when we solve now, we're going to get an odd number because of what it equals. So again, no parentheses, no fractions. I can't combine similar terms, so I box my variable term. I subtract my 6, gives me 3x equals 177. And as I take 177 and I want to solve it for x, I'm going to pull that coefficient away from it and say that x equals 59. Now notice that our answer is non-decimal, which means it's an integer, and also that it's odd. So I take that, go back to my chart, and say my first odd number that works is 59. If I take 59 and add 2, it gives me my next odd number, which is 61. If I take 59 and add 4, it gives me 63, which is my third and final number. So 59, 61, and 63 are the three numbers that if I add them together, they give me 183. So my answer checks. In the third example, for our self-check for integers, pause the video, try this yourself, even though it's slightly different from the other one. Give it a shot and see how it goes. All right, we're going to start off. It says find 3 consecutive integers such that their sum decreased by the third equals 5. So again, notice that we don't have the word is here, but we have the physical equals to 5. So we're going to just set up that right-hand side again, and then we're going to know that everything before has to be on the left-hand side. So we're going to go back to the beginning, and it says find 3. So number 1, number 2, number 3. Consecutive, look at your formulas. Notice this time it just says integers, not even, not odd, but just integers. So the first number is x, the second is x plus 1 as we look at the formulas, and the third one is x plus 2. Then it says such that their sum, so I'm going to add them up again. Notice that it's a different variable expression than the previous two, and I'm going to put it at the start of my left-hand side. Now, building on that, it says the word decreased, and by definition, decreased means subtract and write it in the order of how you read it. So decreased by the third. Now, the third number is x plus 2, and because it's a binomial, I need to put parentheses around it to protect that because it's being decreased. That negative is going to change what I'm doing to that parenthesis. So now I am seeing parentheses, so I'm going to distribute the negative. Gives me 3x plus 3, a minus 1x, a minus 2 as I take the opposite of each term in the parenthesis, equals 5. From there, I'm going to combine similar terms, so 3x's take away 1x, positive 3 take away 2 gives me 1, and I'm just going to solve this now for x, moving the constant terms together, and then dividing by the coefficient so I get x to be 2. Now it is an integer, it's a nice number, and it's going to come back and represent my first consecutive integer. Then I'm going to add 1 to get my next, and I'm going to go and I'm going to add 2 to get my last. So my set of numbers that work are 2, 3, and 4. So I'm going to end the recording here, and we're going to move into the real-life examples next, but this is concluding our word problems on consecutive integers.